Hey, welcome to this tutorial on how to make stacked SmolSlimes. This is an update from my last tutorial. A lot has changed, so a new tutorial is warranted. SmolSlimes are a very small variant of slime trackers. They are a DIY project. However, SlimeVR themselves are making what are called butterfly trackers that use the same technology as in this project, which is great. What is so fascinating about these trackers is that on 110 milliamp hours of battery life, they last 45 to 50 hours of constant use. That is phenomenal, and they are so small. This is about 7.3 millimeters tall, and being low profile, so lightweight, this only weighs 7 grams when it has a battery in it. It is so amazing how tiny slimes have gotten, which is just insane. The variant we're going to be making today is a stacked SmolSlime. This is where the IMU is stacked on top of the board. Here we'll take a closer look. The IMU is stacked on top of the microcontroller board. Now the microcontroller board here handles charging, voltage regulation, and communication with the computer or with the receiver dongle. SmolSlimes can get their battery life by the tracker talking to the receiver and the receiver talking to the PC, instead of the tracker talking to your Wi-Fi. This whole system is so much more power efficient. That's how we can get those amazing battery lives. The dongle signal matters from dongle to dongle. There are ways to improve your signal, and it's at the point where in the average play space you will not notice the difference between these trackers and Wi-Fi slimes, which is fantastic. So today we are going to be making both these slime trackers, these stacked SmolSlimes, and we are going to be making the dongle. Alright, in this part we are going to be showing how to flash the firmware on your trackers. This should actually be the very first thing that you do with your trackers. When you get your supermini, you should open it up, set the header pins to the side for when you make the tracker, and we are going to make sure that this works by flashing firmware onto it and a new bootloader. To do this, we are going to go get the firmware from the SmolSlime documentation. This documentation is very extensive, and it updates very often. So come back here if something seems confusing, or to say something in the Discord, SlimeVR Discord, if something does seem confusing. But as you can see here, we have our tracker schematics, and what we are making in this video is stacked SmolSlimes. And as you can see, this is how our tracker is going to be wired. But here you can find the schematics for the tracker, you can find the hardware that some people use. The hardware in here isn't exactly what I use in my trackers, but everything here should still be functional and accurate information. Here we have a list of pre-compiled firmware, and while this is not the firmware we're going to be using today, it is linked to my repository, however, so it still should all be the same firmware. While this is not the firmware we're going to be using today, it is built off of the firmware I have in my repository. And that is built off of the main firmware. So here you can download things as a UF2 or a hex file. For our Pro Micro or supermini device, we are going to want the UF2 file. And let me just make sure this is the right one. Yes, this is the updated bootloader for superminis, and this will put our superminis in a very efficient state. And that is all great for more battery life. So now that we have our bootloader, we are going to take our tracker firmware. Now you can take it from this list. The recommendation, if you do so, is going to be supermini, SPI, stacked, little sandwich, and either one for wake on motion or sleep. This is the battery saving measure that turns the board off when it is not moving. So that can get you some battery life. It can get you a lot of battery life actually, but it is not very good on your chest or hips. Sometimes the tracker can take some time to wake up because it uses acceleration to wake up and not the gyroscope. So if your chest is rotating slowly without moving left or right, it might introduce some sleep drift, which can be very annoying after some time. But you're going to want to get supermini, either one with a sleep or no sleep, and you'll download it with the link. This is one way you can download it, and it'll come like this file. So you can get your firmware from these links. By all means, it should work. They pull from my repository, which is forked from the main SmolSlime repository. And if everything goes great, it works. If it does not work, however, if something funny happens, you can always try to go to my releases in my GitHub. I'll have it linked below. The firmware in my repository, I make sure that it works. I make sure that it doesn't give me any funny business. And I try to keep it up to date as much as I can. So if the firmware in the docs gives you any sort of trouble, I recommend checking out the firmware on my releases, and all this should work. Taking a note here, if the tutorial today that we're building is going to be SPI firmware. So you're going to want to get SPI. If it's wide for SPI, you can use I2C. But SPI is what we are going for and what provides you a little more efficiency. Here we have SPI one side. That means that 6-sided calibration is disabled. This is my personal firmware, what I use on my trackers. Now here we have SPI one side. That means I have a 6-sided calibration disabled. I do that because one-sided calibration gets me pretty good results, honestly. And it's a lot simpler. If something does happen, I do go back to regular firmware, which has 6-sided calibration enabled. Typically, that doesn't fix my problems, but 6-sided calibration is better. But for me, it's not worth the hassle for the little bit of improvement that you get. Usually, it's some other problem that's causing your trackers to be drifty. And here we have the sleep firmware. This puts that board to sleep whenever it doesn't sense movement. It saves you a ton of battery life. I personally only recommend it for your legs. Your legs, your elbows, just not the trackers on your spine. You shouldn't have any problem with it. Now that we have our bootloader and our firmware, I am going to load them onto our supermini. We do this by plugging it into our computer via a USB-C port. I'm doing this through the camera. As you can see, it'll start blinking slowly like this, and the blue light is going to flash like that this entire time, so I'm just going to cover it up with my thumb. The blue light flashing means it can't find a battery, which at this stage, yes, there's no battery. So we need to put our supermini into DFU mode, or programming mode, as I like to call it. But the official term is DFU mode. Right here is an RST pin. This force reboots the tracker. Well, this force reboots the board. And you are going to tap it twice with a piece of metal. It doesn't work every time. The reason why a piece of metal works is because my thumb is touching ground, and this RST pin is very, very easy to trip. So if I just touch a piece of metal, while my thumb is touching ground on the board, that's typically you short RST the ground, but this works just fine. I'm going to tap it again. And as you can see, it starts to fade in and out. And that is what we want. Now our supermini has opened up into a new drive, like a flash drive, and it is going to be called Nice Nano at first. The first thing we do is we're going to take our bootloader and drag and drop it into the Nice Nano drive. As you can see, it went ahead and it went ahead and disconnected. That is fine. That just means that the board rebooted, it now accepted the firmware, and if you notice, the red light is blinking a little bit dimmer. That's because the board was previously at 3.3 volts, now it's running at 2.3 volts instead. That is the efficiency that we're going for. We're going to do the exact same thing, tap the RST pin twice, and now it opened up a drive called SlimeNRF TRK. This means it has the updated bootloader on it, and we're going to drag and drop our firmware into the drive. It's going to flash like this. It's going to go ahead and reboot again, and now our tracker is blinking once per second. This means it's looking for the receiver dongle. Now the receiver, you're actually going to do the exact same thing. However, instead of using the SPI firmware, we are going to be using the receiver firmware linked in the docs. You'll just download it with this link. SlimeNRF supermini receiver. This should also be the latest firmware that you will flash onto your receiver. But same process for both the tracker and the receiver. Now, let me show you some common issues that may arise from flashing your tracker. Very tricky in the timing on when you tap the RST pin twice. You just need to do it at the right rhythm. It's usually tap tap, tap tap, come on, tap tap, tap tap, like that. So, how did you get the unexpected error that may come up with this? Man, it is being so nice. Sometimes when you flash the supermini, it will give you an error saying that the file transfer was interrupted. You can ignore that. The supermini will typically reboot once it received the firmware, and that may cause Windows to think that something went wrong. 90% of the time, nothing's wrong, which is great. Now, I've had a very good track record with these supermini boards. I have so many succeed, but some do arrive DOA, and I have killed a few others. But it's very low. But this is one that is DOA. As you can see, the blue light is blinking, but the red light is not on. That doesn't mean it's dead. Sometimes if you take sometimes if you short the RST pin, the red light will turn back on. However, here, it doesn't turn on. It does not show up in Windows when you plug it in. This board is unfortunately dead. Sometimes you may come across a supermini that decides to do this, where the red light is just dimly, constantly lit. I have done everything I know how to get this to work, which essentially just boils down to just hitting the RST button over and over and over and over and over again. Nothing happens. And on the back, there are some debugger pins. You can purchase a debugger for very cheap, and these pins can help you sometimes save a board from a bad bootloader. You can erase what's programmed onto it and just program it with something new. However, with this dim light on the red LED, I have had a very poor success rate with that. But by all means, you can try. I do recommend purchasing a debugger just in case you need to. However, this, as far as I'm aware, this is dead. The remainder of the issues typically come from after the battery is soldered onto the tracker. So what we're going to look at here is my personal ankle tracker. And we're just going to turn them on. See, this is a nice and happy tracker. Currently it's using sleep firmware, so whenever I tap on the table next to it, the IMU tells it to wake up, and that red LED is going to blink slightly to indicate that it is weak and it had woken up. This is on my leg. Sleep is great on your limbs. It is just not something I would put on my chest. I'm going to try to make it upset. Here we go. So as you can see, the red light is flashing a lot. This normally happens after flashing firmware onto it. Sometimes this can happen if it reboots a bunch like I was doing to it. Either way, this problem is solved by just hitting the RC pin. There we go, it's now running. Currently, it's giving 2 blinks. 2 blinks means that there is a sensor error. Sensor error means it cannot detect the IMU. This is normally indication of bad soldering, but it was working before, so that's not the case with this one. What it could also mean is that on the board itself, there may be some solder bridging something, some solder paste that may be dripped back. That's why we scrub it off. However, it could also mean that it just needs to be power cycled, which means we are going to reboot it with the button or the RST pin. We're going to use the button this time. I push it once. It's now going to reboot. As you can see, it is no longer blinking twice. So this just needed a reboot to start working as normal. 6 out of 10 times, that is why it is giving an error. It just needs to power cycle. Another issue that can happen is this red light is just constantly red on. I can't get the red light to constantly be on for this video, but that also is usually solved by shorting the RST pin or pressing the button once. If it stays on and remains on, make sure that it is not functional in SlimeVR. And if that is unfortunately the case, that means the tracker is dead. Now, how can we make sure that our firmware took to our trackers? Well, let's take the tracker that we had just flashed earlier, and we are going to plug it in again. As you can see, it's now blinking once per second, looking for a receiver. There is a software called NRF Connect for desktop. And in that software, there is a serial terminal. And the serial terminal is how we communicate with most of our trackers. So here, I have NRF Connect for desktop pulled up. This is just an arbitrary tracker. It's not our actual tracker that we're using. Here we have our receiver. I have the Hollywood dongle. However, the DIY dongle, again to reiterate, will work just fine for the average play space. Here we have our Slime NRF tracker that we have plugged in currently. We are going to select that, connect the port, and here we have our commands that we can do for the tracker. This is where you are going to be setting up 6-side calibration if you want that. This is where you can also set the address of your receiver, or you can enter pairing mode, clear pairing mode, or enter DFU mode without pushing any buttons, or, the best part, you can just meow. Boom. But to make sure that things are working, typically it's good to get the information out of it. So we're going to type info. And as you can see, we have our tracker. We have the date of the firmware that we flashed onto it. We have the kind of tracker it is, what protocol it's running, and here we see that there is no IMU attached. You can't find an IMU, that's because there is none. It has no IMU. But if we were to take our tracker from earlier, my personal ankle tracker, plug that in instead, I'm going to cover the lights. We can now go to that, and as you can see, we see that there is motion from the sensor. If we go ahead and type info, you can see that it recognizes that the IMU is ICM45666 running SPI interface, and these are the calibration biases for the tracker. It is working, everything is great. To make sure the sleep is working, when you have it plugged in, you'll get this message. IMU wake up requested, IMU wake up not available, waiting on ESB status slash ESB slash status ready. This means it's plugged in and it doesn't want to go to sleep while it's plugged in. But sleep is working, so everything's all good. For trackers just running one-sided calibration, you just have to put it on the table and you're going to push the button twice. And it should blink like that. So now we're going to go over the button presses that you will need and what the blinking lights mean. We're actually going to put this back in its case, because typically you'll mess with the buttons while it's in the case. So to start one button, that's reboot or to turn on. That just reboots the tracker, it turns it on. If it's being funny, you can reboot it and that'll restart everything. 2 presses is recalibration. You can see it turns on, and 2 long blinks, then 4 to 5 blinks at the end. That means the calibration was good. If it were to blink longer, let's see, if we were to calibrate again, and now we're going to move it around. It's going to blink like that to tell us that the tracker did not accept the calibration. It moved, it rejected it, and it just kept the old calibration onto it. When you just calibrate it again, we're not touching it, it's not moving. This is what it's going to look like during a successful calibration. 3 blinks is pairing mode. You can also press and hold down the button for a very long time, and that will also put it into pairing mode. Here I push the button 4 times. 4 times is to enter DFU mode, and that only happens when it's plugged in, so it's going to blink at you that it's upset. Now to turn off your tracker, you're going to press and hold the button until light fades down and starts blinking like that. If you do that, the tracker's off. It's going to go into deep sleep where it's not going to use any power, it's not going to transmit anything, it's just going to be off. To turn it back on, you just push the button, it'll blink like that, and you're good to go. And with that, that's all you should need to know about the trackers and the common issues. If there's anything else that is a common issue, please let me know in the comments, and I'll see if I can help you address those issues. That is everything I have for common issues that come when you are constructing the trackers. Yeah, if you think there is a problem, use a serial console. Type in information, or type in info and see if can't find the IMU, if it's having any problems. But typically, if a supermini can enter into the terminal, then it's not the supermini's fault. Something else is most likely at play, and that's a good sign, because that is more fixable than if your microcontroller board is broken. Yeah. Thank you very much for watching. I really hope this helped you with constructing your SmolSlime. It means a lot to me that so many people are making something that I put a lot of time and effort into, optimizing how to make them, how to make sure that this configuration works, and to see people enjoy making and using these trackers is very special to me. Thank you very much. If a tracker starts to blink 3 times, like that, that just means it can't find the receiver. It needs to be paired to the receiver, or you just need to plug your receiver back in. I just plugged in my receiver right now, and as you can see, it stopped blinking 3 times, and we're all good. So before we get started, we're going to do a soldering iron. We're going to need our choice of solder. I like to use solder paste. This is a lot easier to work with and a lot quicker, a lot less hassle. You can use solder wire. If you do, I recommend something lower temperature and to use flux along with it if you need to. What we're going to have a few components that we need to make our trackers. We're going to need our supermini, our IMUs, some buttons to use with our project, like so, and we're going to need a wire of any kind. This can be on a resistor, this is just left over from my past projects, but it can be any wire, so all we want is the metal bendy part that we're going to snip off later. We're also going to do something new from last tutorial. It's going to be called a wire mod. This is just where we add a 31mm wire to our tracker antenna. That way it improves the signal. So first, we open up our supermini. All the parts will be linked in the description below. Some of the links may change, and if I can catch that, I will change them as we go. Well, I will update the links as we continue. We're going to set this tracker aside for our dongle. We're going to set this supermini aside to use for our receiver dongle, and we are going to open this up. This is the red tenstar 2-pack Pro Micro Supermini from AliExpress. This is by far the best deal you're going to get with superminis. They can be very expensive, but at the best, I have seen these things for $1.70 per microcontroller board. And again, this handles the charging, the battery monitoring, and talking to the IMU and the receiver, which all that combined with this is actually pretty good. We're going to take our supermini. We're going to also take the header pins that come with it. And with it, we're going to break off 6 pins and set them aside. And then we don't need the rest. Just the 6. Next, what we're going to be using is our IMUs. We're going to be using the ICM 45686 for this project, but this is a LSM6 DSR. Both of them are from Kuno Lab. However, in the future, and pretty soon, Kuno Lab is going to be not selling IMUs anymore, and instead is giving their files to SlimeVR official for their ICM modules, and data for their LSM6 DSR modules, which will be a very interesting change. Kuno Labs has been around for so long, and it's just weird to see them become official with SlimeVR. It's just crazy. But aside from that, we're going to take our IMU modules, and on the back, I want you to put some tape. This can be any kind of tape. I'm not picky what you put back there. All we need is something to catch any potential drips from solder onto the microcontroller board. Anything will do. You can even use scraps from the packaging to put behind there. And that is better than just letting it potentially drip onto the board, meaning you have to scrap this if you mess with any of the components. That said, we're going to use our ICM 45686 boards. Let's break off here. These have already been pre-taped up in the important areas. So we got our IMU, our supermini, our header pins from the supermini, and our button. For the button, what I like to do is I like to take the button and I like to bend this pin one side downwards. This makes it fit in the hole better. And the button is actually the first thing we are going to be soldering. This is not what I put on first, personally, but when you're learning to make these, this is the most complicated parts. And so we are first going to be putting our button on. Our button is going to go in pin 6 on the board. So this is the battery minus pin, and then pin 6 is the one directly underneath it. Here, let me zoom in more. Actually, let me show you a quick picture of the board. It's just some helpful tips. Just some helpful tips. The numbers indicate the pin directly above them. So pin 17 is this pin, ground is this pin, and pin 6 is this pin. Okay? So we're going to put our button on in pin 6, and then the other end can go onto ground. We want to slide the button up as much as possible, that way it stays away from our emulator. Just push it as far up as possible without, while it can still be steady in the board. And with the button in, we are going to start soldering. It doesn't have to be perfectly straight. This is perfectly fine. Most cases will allow for a little leeway. My cases, which are public, do allow for a little leeway. And we're just going to add some solder paste to the pin on top. You know what? I should really be wearing gloves for this. Here we go. And regardless of what you use, whether it's solder paste or a solder wire, you want a nice smooth finish with the button kind of close to the top. See, it's nice and smooth. It's not clumpy. That is what we want. The next part is the trickiest part, and is also where we're going to be using our wire. You don't need this wire as much if you are using solder paste. If you're using solder paste, you don't need this wire as much. I've stopped using the wire after using paste for a bit. But if you're using solder wire, this capacitor right here, if you nick this with the soldering iron or the solder, it will disable the board when the battery comes to a full charge. After the battery comes to a full charge, it will stop charging, and then the board just dies and it's a bad time. To protect us from this, we use the wire as a railing while we flux up the area and apply some solder to the area to connect the button to the ground pin. You see this is marked ground. The button will connect to this pin, which will be ground, and then our button will be functional later on. But since we're just using flux, we don't need the wire. However, for this demonstration, I will still use the wire. Use the wire, apply some solder to the area. And then use our soldering iron to melt the solder onto the button and the pin without touching the capacitor in the back. Cool. Now with solder paste, it might need a little bit more to make the connection, so we're going to add a little bit more to make the connection. And here we are, nice and smooth, good, strong connection. Moving on, we're going to now be adding our header pins to the board. The pins will go in pin 17 all the way down to pin 11 down here. So there will be 2 unused pins on the bottom, and if you use the same button I did, then it would just fit up right next to it. If you're using solder wire, go ahead and flux up these areas. Otherwise, with solder paste, I'm just going to go in and apply solder paste to the areas. I'm trying to fix the lighting. That's better. Go ahead and apply solder paste to the areas. I like to do it from the far side, that way it doesn't ever come close to contacting the other components. And go ahead and solder on pins. What we want is nice, smooth, strong connections. This all looks great. Actually, might have to add some more heat so that they fully flow around the pins. We want the solder to flow around all the pins. That way, none of them will break in the future and we have to open it up and fix things again and then make us very sad. This one's looking a little weak, so we'll just add a little bit more. Now it's perfect. So now we have our supermini with our pins. I leaned them forward because that just makes things cleaner in my opinion down the line. Now, why did we solder on our header pins before we added our IMU? Wouldn't we want to put it through the holes so that it's nice and snug? No, because if you do that, yes, it will be very good and connected and very sturdy, but if in the somewhat likely chance you need to undo this, you need to remove the IMU from the supermini, it is infinitely harder to do that when you put all the pins through the pin headers. I like to attach them to the side of the pins. These are castellated edges, which allows us to do this and makes the whole thing a lot nicer, in my opinion. A lot easier to undo if we need to. And as someone who makes hundreds of these, trust me, it is a lot better to solder to the side. And I haven't had them break on me being on the side. I haven't had a single one break yet. So now we're going to take our IMU and we're going to line it up with our supermini. For now, don't worry, we're not going to be soldering it just yet, but this is how you'll line up the pins. We're going to take our clippers and we're going to trim down the pins so that they are somewhat flush with our IMU. And with that, we now have our pins flush with the IMU. So here, you want pins lined up like this. You want pin 17 to 3v3, pin 20 to ground, pin 22 to SCL, pin 24 to SDA, pin 100 or 1.00 to CS, and pin 11 to SDO. With these 6 pins, we are using the SPI interface. This is slightly more efficient than the I2C interface that we were using previously in the last video, which only required 4 pins. And this also helps us get a little bit more battery life out of our product, out of our tracker. It's also technically faster, but the main difference is it's slightly more efficient, and that's why we're using it. One thing I unfortunately forgot to mention during the recording is after you've attached your button and your header pins to it, it is good to take some isopropyl alcohol and scrub down the board. This cleans up any messy flux, any sort of solder paste that might be bridging a connection. Just take your board, some isopropyl alcohol, scrub it off, and let it dry. Use a soft bristle toothbrush or something so that you don't damage any components. So with our IMU, go ahead and flux the pins, or if you're using solder paste, apply solder paste to the pins. Hold it down with your left hand, or your right hand if you're left-handed. Just apply a little bit. This first step is just to anchor the IMU to our board with the solder. Cool, now let it cool off. Now that it's anchored, we can apply a little bit more to secure the connections. And this is where the tape comes in, where you'd want to catch any sort of flow down through the holes or off to the side. This is just a lot safer and prevents a potential headache in the future. Cool. Now our IMU has nice strong connections to the side of the pins, and this is a fully functional tracker now. But there are things we can do to improve it. If we want to improve battery life, we can add a wire from int1. We can add a wire from int1 to pin 2. Doing this, we can enable something called sleep mode, which will turn off the board until the IMU senses movement. This is very good at improving your battery life. It can easily double it sometimes. If you don't move a lot, yeah, definitely, you can easily double it. But I don't like it on your chest or your hips or any of the spine trackers. I don't like it because it uses acceleration to wake up, and sometimes your chest or your hips, they rotate without moving without like moving left or right a lot. So the accelerometer won't wake up the board, and you just get what I call sleep drift. So on your legs, it's fantastic. So much more battery life, and you can take off the trackers and leave them around, and you don't have to turn them off because they just put themselves to sleep. It is great. But for your chest and hips, I recommend not using sleep. What I do recommend for all your trackers, especially for ICM 45666, it's actually not, it does nothing on DSRs. This here is an external clock. It helps improve the accuracy of the IMU. We don't need this external clock on when the IMU isn't moving. So we attach a pin from 1.11 or 111 to this pin right here, and that will turn off the clock whenever the IMU doesn't need it. And you can do this with all your trackers. It will do nothing on DSRs because DSRs don't have an external clock, but it's also, if you're like in the groove and making a whole bunch of them, like it's no harm. There's just no point in doing it on DSRs. And look at that. We now have a more power efficient SmolSlime. This is all the pins that you need on the IMU, and this is what it should look like. This is a great example of soldering. Look at that. It's not the best solder job, I know, but for demonstration purposes, this is great. But there's one more thing we can do to improve the connection. We're going to wire mod our tracker now. This involves adding a 31mm wire here. This is any wire. I think this is 26 AWG. Technically 24 performs better, but if you can get this wire, it is a lot better than no wire at all. And a lot of 24 AWG wire comes with a really thick coating, and this makes it kind of difficult to fit in the case. Like, look at that. That's a lot of coating. So any wire that you can fit in your case that's not like extremely flimsy will improve your signal significantly. We're we're going to do this by, if you have a stripper, strip the wire a little bit. This particular wire, the insulation easily melts with heat, so I'm just going to add some solder paste to the right side of the chip. And we are going to put a little bit of the solder paste onto our wire. And then with our soldering iron, we're going to melt that solder paste. You can do the same thing with flux. And it just melts right back. Bend the wire, attach it to the side, and go ahead and solder it on. Solder on and hold it there until the solder fully cools. And here we are. This one's actually a little bit short. I cut this short, but this is now a tracker that has significantly better signal, significantly better battery life, and it is fully wired. It just needs our battery. Now, moving on, we have our battery. I like to attach the battery to the B+ pin here and the ground pin here. On this board, ground is battery minus. So any sort of battery negative. Any ground pin you can use for the negative wire on your battery. So we're going to go ahead and solder it on. All right, our tracker now has a battery. With the light blinking like this means that there is no firmware on this. You should have uploaded your firmware before you started building the tracker. It just troubleshoots if the board itself is functional. But assuming it has firmware on it, now we take it, we put it in our case. It's nice and snug, pull the wires kind of down so they're out of the way. And we put our lid on. And we have our tracker. And congratulations, you have now made a Stacked SmolSlime. You have made something that is very small, very power efficient, and can be used without messing with Wi-Fi. This bypasses all the Wi-Fi problems I had. This is great. Now we're going to show you how to make the dongle. To do this, we use this yellow PCB antenna from AliExpress. I have done a lot of trial and error with antennas. For the ratio of performance to ease of use, this is my recommendation. This will give you a very good experience, especially if you wire mod the trackers. What I do is I take some flux and put it on the left and right side of the C3 antenna. We want to be kind of careful because if we are too rough, it will probably rip off the antenna from the pads, and we want those pads to be intact. So when I'm being lazy, I'll use tweezers. No, when I'm being lazy, I'll use clippers to grab onto the antenna, but for the sake of tutorial, I'll use actual tweezers. Grab onto the antenna. With the soldering iron, heat up the left side to soften up solder. And then with the right side, you'll start to twist and pull. Be very careful. And I mean, on the right side, just pull the antenna off very gently, but don't be so rough that you're going to rip it off. There we go. And don't leave the iron there for too long, otherwise you might burn the pads off. But here now we have two beautifully exposed pads. The left one is literally nothing. It is only there for support. So that's why we value the right one over the left, because the right one is what actually matters for our antenna. With our PCB antenna, we want to attach the inner wire to the right side. If you don't see this inner wire and there's like a connector on it, you can try to rip the connector off, and that might expose the inner wire for you. Otherwise, you might have to cut off the outer coating to get to the inner wire. Now, this one came as solder or whatever the marking was, but did not have a connector, and that's what I recommend you get. We're going to take our antenna, we're going to line it up with the pads, and then we're going to apply our solder paste to the right one first. Heat it up. And that is all you need to do to create a better antenna on this receiver. For stability's sake, if the left pad is survivable, I also like to attach the left side to the outer wire of the antenna. And we do this for stability. That way the right side of the pad doesn't get any stress on it. It's nice and sturdy. Oh, it was not fully cooled. Yeah, that wasn't fully cooled, but now it is. Nice stability. All right, and once you have done this, you should have flashed firmware onto it already to make sure that the supermini works. With the receiver firmware flashed onto this, we can put it in the case. Put the lid on the case. And now we have our dongle. And yeah, thank you so much for watching. I hope this helped you build your stacked SmolSlimes, whether it's the receiver or the tracker. It's very nice to see people make and enjoy something that you spent a lot of time building and optimizing the process to make something that you really enjoy. Like, I love these so much. It's been disassembled, but these were my first trackers. They're shorter. At the time they were smaller and shorter than the most, with just a massive battery in them. But they were bulky and they caught on things, and when I first started making SmolSlimes, I just adored how they felt, how low profile they were, how they didn't catch on anything. Like, this is just as tall as the strap handle. That's crazy. And just seeing people watch my tutorials and it being helpful to them, it's... Thank you for watching, and I hope this did help you, and I really hope that you enjoy your SmolSlimes. Please write in the comments if you have any questions or want tips on how to do certain things I didn't cover in the video, and I hope you have a great day. See ya.